taking up the questions in 1.6, I have outlined the steps. It's basically 4 steps when we're solving by substitution, and those 4 steps I've put right here at the top. The first step is to solve one of the equations for one of the variables if you don't have that already done for you. So if I look at equation 1 and equation 2, I don't see an x equals or a y equals already, so I took equation 1 because it's the only one that has a coefficient of 1 in front of one of the variables. So equation 1 is the easiest one to solve for the letter x. So I solved equation 1 for x by subtracting 2y from both sides, and I got x equals 7 minus 2y. And then I took that 7 minus 2y and replaced the x in the second equation with the 7 minus 2y. So I have 2 times 7 minus 2y plus the 4y minus 4. And then I expanded the 2 through the bracket, and I got 14 minus 4y plus 4y equals negative 4. And in doing so, if I have negative 4y and I add 4y, the y's end up canceling each other out and they go away completely. So I'm left with a statement of 14 equals negative 4. And that's untrue. 14 will never equal negative 4. You'll never convince me that that is true. What this means is that this system is a case where we have parallel lines that do not touch each other. There is no intersection point at all. So when you get an untrue statement, these lines are parallel and there is no intersection point, which means there is no solution. There is no solution. There we go. The lines are parallel and there's no intersection point. Apparently I like to put not instead of no. There is no solution in this case. If I would have taken this, these 2 equations and got them in the y equals mx plus b form, I would have seen that they are parallel and distinct lines. Okay, moving on to the second example. All right, solved by substitution. The first equation was solved for y, so I did a direct substitution of 1 into 2. So where I have y in the second equation, oops, let me try this. There, where I have y in the second equation, I replaced it with the minus 3x plus 2, which I had y defined as. Expand that through, collect like terms. The 3x's, take away 3x's equals 0. It leaves me with a true statement this time. 2 is equal to 2. If I were to take equation number 2 and put it in y equals mx plus b form, I'm going to get negative 3x plus 2. When you get an always true statement, like 2 equals 2, or 4 equals 4, or 0 equals 0, or negative 25 equals negative 25, we have the case where we have 2 lines that lie on top of each other. The 2 lines lie on top of each other. So this is a case where we have an infinite number of intersection points. There are an infinite number of solutions or intersection points. Okay, and every point has the form of, let me just go back to my stylus here, the solution. I got a new stylus, so the other one was really hurting my wrist after time because of the rubber creating so much friction. The solution is in the form of x, comma, and then y is equal to negative 3x plus 2. So whatever value I pick for x, I can pick anything in here. So let's say x was 1. I would then put 1 in where the x is for there, so I'd have negative 3 times 1, which is negative 3. Negative 3 add 2 would be negative 1. There is a point on the line. Okay, or I could put like 0 in here for x, put 0 in for the expression for y, and I get a 2 out of that. That's another intersection point. And I could just keep going on with that infinitely. But instead of listing an infinite number of points, which is really impossible to do because it would take forever, let me just double check my work. Negative 3 times negative 1 is 3. Plus 2 is 5, yeah. Instead of writing out every infinite point, which would be impossible to do, we just write it, let's redo. We just write it in this format and we say you could have any value of x and the y has to be expressed as negative 3 times that value of x plus 2. Okay, third one. solve by substitution. This one has some things like fractions, which we don't like working with most of the time. So we use our ideas that we had from our first review unit. What I've done here is I took equation 1 and multiplied every term by 3. And in doing so, I come up with this equation of x plus 3y equals negative 3. That looks much more comfortable. Similarly, equation 2, I took and multiplied everything by 4. And by multiplying everything by 4, I ended up with an equation of x plus 2y equals 4. These two equations, I've just labeled it as 1b and 2b because really it's equation 1 but in a different version, and this is the same equation number 2 just in a different version. If I were to graph this equation 2b on Desmos and my original equation on Desmos, they would be exactly the same line. So I haven't changed the line at all by doing that. Then I went through the process that I had outlined before. I solved 2b for x. I didn't have to do 2b. I could have done 1b for x because it also has a coefficient of 1 in front of the x. This was just what I chose to do. Then I subbed that into equation 1b, solved it for my y equals negative 7. I subbed that back into 2b just because, again, it doesn't have any fractions to work with. I got x is equal to 18. And my solution is 18, negative 7. Now I can always check my answers by doing a left side, right side check. Left side, right side. So I could check equation number 1. My left side is x over 3 plus y. And my right side is negative 1. If I do 18 divided by 3 and then subtract 7, that's going to give me 6 take away 7, which is negative 1. So I know that that point definitely works on equation 1. And then I check equation number 2. So this is just another way to know on your test whether you got the right answers or not. You can always go through at the end and double check your work and make sure that they all work out. We have y over 2, and that's equal to 1 on the right side. If I do 18 divided by 4, that 18 divided by 4 plus, and then the y gets divided by 2, negative 7 over 2. So 18 divided by 4, that will be 4.5 plus, and then 7 divided by 2 is negative 3.5, and that's equal to negative 1, sorry, positive 1. I made an oops. Positive 1. So my left side equals right side again. I know that that is the solution. It definitely works. Okay, last example. All right, this one we also need to do a little bit of work with. What I did is I took equation 1 and I said, you know what, that doesn't look so good for me. I'd rather have it simpler, so I expanded it through, collected like terms, and put things in the x plus y equals a number format. I did the same thing with equation number 2, made it more comfortable for what I was looking at. And then I went ahead and solved 1b for the y because it was the only one that had the coefficient of 1 in front. I got y equals 14 minus 2x. I subbed it into equation 2b, got x equals 5, subbed that back into my 1b rearranged, and I got y equals 4. So my solution is 5, 4.